Not really. They need to learn their math skills again. What?
Who's doing the math?
Oh, seriously. Someone also shut down. My Elmo. I'm just loving this. All right, that person is not going to be shutting things down because that's not so helpful to me. Because they shut down all my stuff.
She doesn't have an option to find whoever is doing it.
No, I don't.
But she can tell him not to do whatever he did.
Yes. It means after my next doctor appointment, I'll have to come back up here, cover everything, and then get to go back home. And I'm not supposed to go back to work after my nerve blocks. Why is this not showing up? Okay. This image mate. Okay, share screen. There we go. That one, share.
We're back on track.
For a moment. I'm waiting for it to. Oh, come on. I know you're going to stop sharing. There you go. There's my little friend. I know you're going to stop sharing for me. There we go. All right. Now we're with it. Okay. Now we're back up and going. And I actually got it going faster than I've ever got the entire system going before. It's only 8:23. I lost 3 minutes, which is actually phenomenal. The greatest thing is, this was after one of my meetings with, you see all this writing in my book? That's from a year ago. And they told us last year, don't write in the book at all. And I found out that all the other teachers in the district laughed at them when they said that. So that's when I started writing in my book, and all these written notes are helpful to me. So I know what to show you guys to be helpful. So it saves me a little time. It helps you guys. Okay. Has anybody ever seen anything like this?
Yes. I've seen a bunch of them.
You've seen a bunch? Where? You've seen them in video games? Has anybody ever seen that in person?
Yes.
Who? You forgot where? Did you see it in Mexico? You didn't see it in Mexico. Did you see it in Texas on the way to Mexico? Once in Texas? Do you remember how big it was next to your car? Humongous. Those blades, each blade. Has anybody ever been up close to one of those machines? You have, Michaela?
Yeah, it was big, but it wasn't like that big. It was like a smaller one, but it had like a bunch more blades.
I was close enough.
And it was in my aunt's yard.
Okay, so look at the bottom. Look right here. That's a building. That's a building.
That's not a building.
Each blade is 100 feet long. Each blade is 10 stories long.
If that blade dropped on that.
It'll kill it.
Yeah.
That's a building.
Like a skyscraper.
Those are humongous, guys. That would be like a fan. Anybody know what that's called?
A wind turbine?
A wind turbine. You saw it at the top earlier, right?
Yeah.
Yes. What do you think the purpose of that is? What about energy?
It looks like a little fan.
Please put the desk back where it was.
For the building?
Looks like a windmill.
It creates energy from the community. It looks like a windmill.
It does.
What is it getting us energy from?
Wind.
Wind.
The sun is
That is a real sun. That's not a fake sun.
It looks like it's shining.
It does. Do you notice there's more than one in that picture?
Yes.
There's 5.
There's 5.
Yeah.
There's 5 in that photo.
There's one way back there.
But do you see there's one street that seems to connect all those together.
Yes. And I see a car.
And
And then it goes
Oh,
to
where?
the.
I see a car on the road. Oh yeah.
Yeah, me too.
the car looks tiny next to those things, doesn't
It
it?
does. That blue tiny car. It's right there.
Or maybe that was our car.
It does.
Gigantic.
Okay. So do you think those are the only 5 wind turbines around?
No.
There's probably other wind turbines that we don't see, right?
Yeah.
So you think those are there to collect energy?
Yes.
Yes.
Do you think they're somehow combined?
Yes.
Since there's 5 of them, there's probably more,
Yeah.
and they're collecting energy. They have to have some way of collecting the energy that those things, the blades are picking up the energy, right? Because the wind's turning the blades.
How is the one that stops make like a
Well, we want to know.
Well, it's
what
not 1,000
collecting
pounds.
is.
It is heavy, but we're going to learn all about wind turbines. Those are amazing, right?
Oh, it's so heavy. How does the
Are they bigger than
Wait, there's a
windmills?
question.
They are.
How do they get made when they're heavy?
Oh, yeah.
Well, we're going to learn all about wind turbines.
It's called a forklift.
And it's more than a forklift. Okay. Okay.
King Crane's place put it up.
Okay. Class. Let's listen to. I got to take my tabs out. All right. So they use the wind to make something happen. Wind turbines are about 328 feet tall on average. In other words, about the length of a football field, right?
You can say that.
100 yards, right? Isn't that the length of a football field?
Bigger than it. Did you
Oh,
say
we'd make a hole in the ground.
382?
This one's 328 feet tall on average. In other words, there are larger ones. That's an average size one.
That's just a regular normal one.
So it says that's the height of a 30-story building.
How old is this?
Oh, yes. This is only 2 stories. It would be 15 of these schools stacked on each other.
Oh my God.
15?
Stack 15 of these schools right on top of each other.
And
And that would be the height of an average wind turbine.
Imagine
Yeah, I would have like going up the stairs and looking out the window.
See
Yeah.
how high you are.
All right.
Then you would have to walk down all the way.
So you guys said that is designed to catch the wind, right?
Yeah.
Does it look like it's designed to grind wheat?
Yes.
No.
Yes.
He says yes, others say no. So do you think it's designed to harness the wind?
Yes.
Yes. Yesterday we used a windmill that did what?
Made energy.
It made energy, and we saw that energy when it did what?
Yesterday.
What did it do?
What did we do yesterday?
Come on, guys, what did our little windmill do? It lit up a light bulb, didn't it?
Yeah.
So what do you think that wind turbine is doing?
Making energy.
Making energy, and it says maybe it's sending energy to the farm in the picture. I don't see a farm, but I do see a lot of what looks like
Very fertile land.
very fertile land, right? Can we agree that that land looks very, very fertile?
Yes.
No, it looks like the sun is setting in.
Looks like
It does, but that land looks very fertile. And look how it's plowed.
much wheat.
So I could
Look.
see farmers living there.
Yes, it does look like farmland, doesn't it?
Yeah. Farmland with a lot of
So
farmland.
this could be sending energy to that farmland
Yeah.
to be used for the farmland, right?
That's what I
Okay. I'm going to show you 2 pictures, and you have a notice and wonder chart on page 7. And you're going to give me 3 notices and 3 wonders about each picture. I encourage you to use these words. These words when you're doing your notice and wonder. Transfer. Carry.
Calculation.
No. Travel. Flow.
How do we use those?
Have. These words have to do with energy. They have to do with electricity. Doesn't that seem like what we've been talking about when we're talking about windmills?
Yeah.
When we're talking about wind turbines? You haven't seen the pictures yet, so you can't do any notice and wonder until I show you the pictures.
That looks like a future windmill.
It does look like a future windmill.
Yeah.
Okay, so I'm going to show you pictures. Those words might help you discuss what's going on in the pictures. Okay? 2 pictures I'm going to show you one at a time. 3 notices, 3 wonders for each picture. All right? That's the first picture. That is.
Yeah, what is a big lump?
I don't know. That's not a pump. That's on water.
It's a submarine.
It's not a submarine. Look, guys.
Maybe it's the energy that flows through the water. Tubes. Oh, it takes the energy. Oh, I
Rising got it.
3 notices and 3 wonders. That's your first image. 3 notices and 3 wonders. That's image 1. That's image 1. Number them, please. No. Your first notice and wonder. Your second notice and wonder. Your third notice and wonder.
I see.
1, 2, 3.
I was supposed to have 3 on
2. Yes, 3. That's what I said.
yeah. Maybe water has something to do with it.
So this time we're not going to do a class notice and wonder, but we are going to discuss what we notice and wonder, okay? The paper on the board is for a class anchor model and for a driving question board. wind turbines. Probably.
Because there are different sizes.
There are different sizes, but those are probably the same size. I'm not sure.
I think one of them is different, but I can't really tell. It's probably because they're further out. Oh, yeah, that wasn't the way that's. Do they have to get in the water? Is that?
If you're still working on your 3, raise your hand. Okay, you got 1 more minute. STR. UC. TURE.
But how would they get the energy if it's in water? And there's only 2 things to it. So they have to connect.
All right. Tell me something that you noticed, Kaylee.
I noticed that they are connecting.
They are connecting. How do we know they're connecting? There are 2 tubes. What do you guys think those tubes do?
Take the energy out.
Take energy out. It's collecting the energy that they're generating.
How do you build them?
That's a good wonder. How did they build those turbines over the water?
That's one of my questions.
Did anybody have the question, why are these turbines over water? If you don't have enough wonders, you could write, why are these turbines over water? If you don't have 3 questions, you could write one of your questions, why are the turbines over water?
I know something with turbines and windmills have to do with water.
Who in here's been to the beach?
Oh, that's when you don't get sunburned.
I have.
Or have to get sunburned.
I'm not asking about sunburn. Has everybody noticed that at the beach it's windy?
Yeah.
Didn't we discuss yesterday that William had to build his windmill somewhere where it's windy?
I guess we did.
So why do you think those turbines are over water?
Because it's windy.
Because it's windy there. Remember, a requirement for a windmill is a lot of wind. So the question of why would they put wind turbines over the water? It's windy. They gotta have somewhere where it's always windy.
I said I noticed water has something to do with it.
It does. Because notice there's 1, 2, 3, 4, 5, 6, 7 wind turbines that we can see. Do you think there's other wind turbines that we don't see? Oh, I'm sure there are. Do you think it costs a lot more to build that over water?
Yeah.
Oh, yeah. No. way
Well,
more
they
than that.
made it before. They put it, maybe there wasn't water there before.
Each one of those windmills costs in excess, starting $15 million over water.
$15 million. Who's buying it?
Over. Generally, it's governments that pay for that. Because They tend to be over ocean water because that's where it's windiest, where they tend to be. That's where it's windiest because you want constant wind. But salt water causes a lot of corrosion on all that metal. So you have significant costs, financial costs. It's a trade-off, financial costs versus your basic resource of wind. Now, do those have to be connected to each other?
Yes.
They do, because how many tubes do we have coming out? You guys pointed out too.
And if there are two of those and there's some of those, might be located somewhere else.
There could be other tubes. So another one of your wonders, if you don't have 3 wonders, is, are there other tubes somewhere else? Another tube could be,
All the way there.
where is this?
This is in a rocky area.
Oh no, this could be lots of different places in the world.
California.
Oh, this is around the world. They have wind turbines worldwide.
Why is it rocky? Does it need to be rocky?
That could be another wonder. Yes, ma'am. Good question. How do they fix them when one breaks down? Because they do need repairs.
There's water.
What happens when storms come? That's a really good practical question. That when a storm, depends on what part of the world you're in. Because guys, that is a significant problem. When hurricanes come, when any kind of storm comes, it causes significant damage, and repair to those things is expensive.
What happens to the, is that a lake or an ocean?
Don't know. We can't tell.
What
No.
happens to all the animals?
We're going to talk about some of the limitations of these later on, because there are significant limitations to these.
Using helicopter.
No,
And you can see that it goes into the water. Yeah,
they do go to the ground. Does anybody notice those little rings at the bottom of those poles?
Yeah, that's not it.
What do you think those are for?
Maybe to hold it.
Water level.
To make sure it doesn't flood.
It has to do with water level, but who in here has been on boats a lot? Okay, now that's your clue. What are those circles around the poles for?
The boat.
They're for the boat drivers to see,
Yeah.
so they don't run into the poles, especially at nighttime.
Yeah.
It's visibility markers.
No.
Yeah, it would. You could kill the person.
Yeah.
Guys, you got to imagine those things at the bases are very big. For a boat driver, that could be catastrophic if they ran into it. To kill 'em.
The picture's taken far away.
It is. The picture's taken far away. Yes. It takes a bit to repair it, and they have to use boats and cranes to repair it, big boats. It costs a lot to repair them. And that's the other thing. This is supposed to be green technology, meaning you don't use fossil fuels when you're using this. That's the whole idea, is that you're not using fossil fuels. You're using recyclable energy. Wind is recyclable, right?
Yeah.
But to get those out there, you have to use a boat. Don't boats use regular fossil fuels?
So like you need
You have to use
Boat.
a big old Navy ship with some cranes on it.
tens of thousands of gallons of fossil fuels to get one of those out there. And to repair one of those, pull your mask up. To repair one of those, you have to use tens of thousands of gallons of fossil fuels. Pull your mask up, baby. So it has a positive and a negative. And that's the reality, is that it does require fossil fuels for repair and for setting it up. So you do have that goes on, but
Can they do anything to avoid storms?
no,
They
you can
can't
see
always-
clouds, but again, you have negatives to that too. But that makes a lot of energy, a lot of recyclable energy, a whole lot.
When it goes out
And
of the,
it's clean energy.
so you can, I can't really tell, but like it looks like it goes farther back, but like where does all the energy go?
It's coming up on the bank into those tubes, and my guess is there's probably lots more tubes elsewhere. That's just a snapshot of where those tubes are. Okay.
That or there's tubes underwater connected to
Tubes underwater probably connect each one of those wind turbines, and there's probably several tubes between each one of those wind turbines.
or there's just away from you.
All right, did everybody come up with at least 3 notices?
I have one.
Tell me something you noticed, Hunter.
I know
There are rocks under the tubes. And that might be to prevent erosion where those tubes are going over the bank. Because those tubes look heavy, don't they?
Yeah.
And they're carrying electricity.
That's why they have that wall.
So they might have that rock wall there for that purpose, prevent erosion.
That and so they can hold the tube up.
Tell me something else. Tell me something else you noticed in Sensei. What's the wonder? Wonder where the tubes lead to.
And how do they collect it?
How do they collect the energy? One of the other notices, you could say that you notice those circles around the poles, because that's a practical consideration. I hope that nobody hit a pole before they figured out they needed to
That was
circle around it.
my
Melanie, does the energy flow smoothly inside the tubes? I hope they don't have surges.
It has
Probably rust
If
like
it,
the
if
river.
it don't, it will break the tube.
I hope not. Yes, ma'am.
How many wind turbines are traveling or carrying the energy?
How many wind turbines are contributing to or carrying that energy?
7 that we can see. Since this is taken further back, you probably can't see all of them.
Oh, probably
7
can't.
of them.
There's 7 right there, but there might be 100 on that farm.
Yeah.
They're called wind turbine farms. There might be 100 in there. There might be 95. We just don't know. There's just 7 in that picture.
Just a good place
Yeah.
for us women.
And in the other one, there were 5. How much did the tube cost?
How much do the tubes cost? Okay. It costs less to have a wind turbine on land than it does on water. These are things that I looked up for practical considerations last year.
That makes sense because the water's
It's harder to get to the lake, to the water, but
So they
you have a
get more
lot more
expensive.
wind.
How much energy has one wind turbine?
That's a really good question. How much energy does one wind turbine generate?
So,
That's a really good question, guys.
if there is energy and it's going up there, there has to be like somewhere it's going.
I'm thinking it's through the wind turbine, but we're going to discuss
How much?
where it goes after the wind turbine too. We're going to get to all that. We're about to get to it on the next picture. Well, it'd be how much each one produces times 7 if they're all equally generating energy. Okay, so let's get to the next picture. Let me get to the next one, okay? Because we have 2 pictures we're doing. Okay, Elmo, stop messing up my picture.
I did not think it would look like that.
Yeah.
Oh, there's one.
All right, so wind turbine,
Power lines.
you have this, this.
Oh, I get it now.
These look something like what we have outside.
We have them all over the place.
And then homes.
Started the first line and then follow it. Oh.
Okay, so 3 notices and 3 wonders.
Wonders are easy.
Yes.
No, because you notice a lot of things when you look at this. Is that a factory?
I think it's trying to tell us that the energy starts on the home, goes to that, and then get the wind turbine.
We have those literally
We do, but the ones we have outside are different because they're set up to generate energy to us from coal. Nope. That's not a generator. Okay, I'm naming the obvious. Let me see if I can make this clearer. I bet it's not.
I think someone like probably. Why do you have a small little?
That did not help any.
The electric, that thing? No, not the wire. How do you always have it? Yeah, what is that thing? So it goes like this and then it goes up that way. What's it do? I noticed there is houses. I noticed houses.
Okay, I'm trying to make it easier for you guys by making the shadow.
Oh, it's fine. I wonder how does the energy from the sun get to I wonder what the lines have to do with it.
All right, guys, we're doing this quietly.
You gave us 2 notices and now we have to do 1. I don't know.
I've been spelling turbines wrong the whole time. I'm spelling turbines.
Yeah, we're not talking about turbines.
Yeah, I didn't think we were.
That's a real thing. No. A factory. We don't know for sure that it's a factory, but that's how a factory would look.
Correct.
And I wrote turbines so many times.
All right, quiet.
I think those are like poles.
Name them as you wish.
No. Yeah, it's gonna rain.
That's not rain yet, though.
It's supposed to a lot. I know, I did not fall.
Okay.
Actually, wonder if it's hard. The red lines things you call. I call them red lines.
Power lines for red lines.
I think they're wires.
I'm steering line. You know what I'm talking about.
I don't know. We'll have to look at it together.
Is it an energy box?
Looks like someone got their hair electrified.
Huh?
Looks like someone's hair got electrified.
Why?
Looks like I forgot to put silicone in my hair.
Huh?
What does?
Silicone?
Yeah, my hair is frizzy if I don't wear silicone.
But how come they're all the same? Why do you keep on saying silicone?
That's what I put in my hair. Frizzy hair, but no.
Wait.
Nobody else has to use silicone in their hair. Really? My granddaughter really has a frizzy hair.
Yeah. Because it looks like it goes into the factory, but you can't tell where it goes.
What is it?
The restroom?
The blue thing.
Right there. Come from when they get out of it, where do the wires go after they get out of the factory?
Come on, guys, you have 1 minute. You only have this extra minute.
I wanna have to notice the one that
Class 3, I hardly know the one first, I do know some of them.
they're way in the water.
Wait, are those wind turbines in the water?
Yep.
Those are not. Those are on land.
Okay,
That
so
looks
why,
like it.
why are they so close to the house? To the house?
It's supposed to be a schematic drawing.
So could we ask that question?
Sure. Go for it.
And I noticed that the wind turbines are fake.
That's not a notice.
Yeah, it's totally noticed. It is fake. I noticed that. I wonder if the red lines are power lines. They are. I know they are.
I noticed. This is how
I wonder what the factor has to do with everything.
it gets energy. Why would we have to?
Okay. Go to where all my answers are. No, you don't like a paragraph. I'm sorry.
Today. What does that mean?
Give me a few. Not today.
Yes, we do. Today, all right.
No.
Today.
Okay.
We have a second block.
What did you notice about the diagram of the wind farm? What did the red lines do? They connected everything, didn't they? They connected the wind farm to the houses, right?
Yes.
And they went through all the little things in the middle. Yes? We can all agree on that. We might not know what all the names are, but they connected everything, didn't they?
Yeah.
We think they're power lines,
Yeah.
right? And we have power lines where we live, right? Like
I see
literally
it.
right
I
out
see
front,
it
right? When the power doesn't work, our lights go off. Our internet goes off. Our TV goes off. Our cell phone chargers go off, right? And we sit in the dark.
Yeah.
Right.
Unless you have candles. Candles and sparklers.
Tell me a wonder about that second picture. Give me a wonder about the second picture.
I wonder what the power lines have to do with it.
Okay. Michaela, why are there lines by the houses? Okay.
How much does it cost?
How much does all that cost? Because it looks expensive, doesn't it?
It looks like
It does. Aaliyah, does it what? Does it move? Does it end? Okay.
I wonder what the factory does.
Wonder what that factory does. Good job. Okay. Okay. Anybody else have any other wonders? Maya, you're very quiet. Looks like you're asleep. Sit up. You got any wonders? I'll make you throw some. Give me a wonder. You're supposed to spend 5 minutes until exercise. It's 9 o'clock. I kind of went over.
Yeah.
Come on, Maya.
There's a back to it.
Oh, yeah, we still got lots of stuff.
What?
Yeah, we got lots of stuff to go. We got the majority of the lesson to go. Give me a wonder, Maya.
I have to know it.
Come on, Maya, give me a wonder. Today. Okay. Today. We need today. No. No, tomorrow we're gonna be playing with other tools in here.
What did you say?
Nothing.
We're gonna be playing with blades. I know how to
Friction cars, a light up hand crank flashlight,
That's not fun.
sand block.
It sounds fun.
Come on, Maya, give me a wonder.
It's a block that's shaped.
Sandpaper on a wooden block.
What? Oh, that's a.
Or, you know, just sandpaper on someone's arm if they won't stop talking.
I don't like sandpaper.
I love sandpaper. Oh, I love it.
Good to hear. Yes, it is. Come on, Maya, give me a wonder. There's so many what? Come on, I want to hear your question again. Turbines, why are there so many turbines? Very good question. Okay, now, y'all have to promise you're not gonna laugh at me because I have to draw an anchor model. And I'm bad at drawing.
You want me to draw?
Yeah, I'll draw you. You can draw that one.
That's like water.
Easy to draw one.
And I can't take up the whole paper because remember they like me to write a whole paragraph afterwards throughout this module. This shows you how bad my first drawing was in class.
Let me see. That looks really good. I didn't see it.
Okay.
Are you gonna use the colors of it?
Sure, the colors are brown, black, and green, and orange.
Orange.
And red and black. Orange,
Red
red, and black.
Red and black is
Oh, the exact.
I guess I can do pencil for the base.
Yeah, and like
If you
sketch
color it
out.
wrong, everybody in the class is.
I colored it wrong.
I didn't even draw one.
You want it from here.
I was.
Thanks to focus.
It was.
I can see you be black because how much you got.
Allie.
Class, push.
Push up.
Look at that.
Push me up and down.
Yeah, my outside wood.
Look at my pencil.
She's gonna fix it.
I know.
I can't.
Why don't Miss Vanderbilt likes sarcasm.
Yeah.
She is sarcasm.
Yeah.
She.
All right, class.
Yes.
Thank you, quiet. It's great.
Oh, so you have to make the base too?
Yeah. Base holds things, does it not?
Yeah.
Okay. Base next, right?
Now you do that whole thing.
I just called it in. I just called it in. You called it a very first part? No, the thing or this is the last part. This is the four. This is the
would be weird.
Girl, you just trace it. I trace anything. I trace the part of the board.
You traced them. Oh, yeah. What? What's going on in this class? Why is
Class, quiet.
You have to go wire.
Yes.
Oh,
we had to go?
but I did it.
Well, go ahead and draw it.
Look at here.
You can draw it now because if you have a bunch of E's, it's gonna kill the grade.
That's mine.
How much ease do I have?
I don't know right now. You see, I'm kind of busy.
I have like two. That already looks really good. I don't have
We gotta color it.
The only thing that has to be in color is
blank.
the red wire.
So you got it all.
Can I just have this blank?
There we go. Ooh, well, mine is a flower. It's called sunflower time.
Called what?
Nothing. Sunflower time. Sunflower time.
Yeah, mine is sunflower.
Mine is little penny.
Yeah, it wasn't mine, but. Okay, so
Okay.
draw that little thingamabob.
Not a thingamabob.
Oh, left out something.
So we call it the light bulb.
No, this thing.
It's called a windmill.
No, I mean that big kind.
Did anybody else draw this little part back here behind the
I just did.
blade?
I think I do.
I just did.
If
I
not,
did.
go back and draw it
I
later.
do.
No, this part right here behind the blade.
I do it, but mine's
Because we're gonna learn about that in the coming days. It's very important. Okay. That is drawn. Oh, arrows, window blades, to the lights. Tells me I need to show wind.
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 That's a family windmill.
Wires connected to the windmill, light running on. Okay, so we have wind, we have light turning on, wires connected to the thing. Oh, and we got an 8 parts of it.
Okay, so why do we have to?
Our windmill, I need all that talking to stop. Our windmill does what? What does a windmill do?
Works.
It does transfer energy, but this is what we're talking about specifically. Harness is what? Harness is wind.
Going right into the bottom blade.
This thing right here behind the fan blade, that little silver thing, it kind of looks like a box, doesn't it?
It looks like a light bulb.
No,
It looks like it has like these stuff in it.
it does. It looks like it has something in it. Oh, look at this. You're back there talking, you're missing the lesson. This looks like a box, like it has something in it. It must play some kind of role, otherwise it would be there.
Maybe it helps the wires.
Something. This, any ideas what this could be? Wires, but what do you think those wires could be?
They make the light.
They pick up the energy and give it to it.
Something to do with energy, huh?
Yeah. Energy wires.
Okay, I'm gonna write in there in pencil, because we're gonna learn more about it later. I'm gonna write energy with a question mark. Okay? Energy. LED light. LED lights up. Okay? When blades spin.
When
When blades spin. These blades spin. When stop talking. Wires. Electricity, energy, LED lights. So we think some kind of energy moving through the wires, right? So energy, the term we're supposed to be defining. Someone, did I hear the word electricity? I know I did yesterday, but did anybody say the word electricity today?
I think it was you.
Somebody else looked at this time,
The lights need electricity to turn on.
Yes.
Okay. I heard a lot of the word yesterday, but I haven't heard it today. Power.
Oh, yeah.
Wind has power that moves through the blades and the wires to the light, right?
Yes.
Okay. Energy is necessary to make something happen. We're going to explore energy throughout module 2. Module 1, we explored weathering and erosion. We're going to explore energy throughout module 2. Okay? We're going to explain phenomena such as windmills turning on lights. And we're going to explore windmills grinding wheat. Okay? Power is not the same thing as energy. They're two different things. Okay? Power is the rate at which work is done, or the rate at which energy is transferred. We're not going to discuss power in this module. Instead, we're going to talk about the term energy. Okay, they're different things. All right, guys? Okay. So this question on page 8, this is going to be the question you write in your notebook. What is energy? Okay. go ahead and try to answer that. Okay, so what did you write for what your understanding of energy is, Bryson? Okay, so energy can help us do things like turn on TV. So you're thinking of it in terms of electricity. Okay. All right, what did you write, Ricardo? Okay. What did you write, Michaela? Okay. Kimber, what did you write? Helps you what? Yes. What did you write, Aaliyah? What is it? Wind is energy. Kimber's words are true in more than one way. You guys are missing a big part of energy. When you guys are really tired, you say you're out of energy, don't you?
Yeah, we have energy.
You do have energy. You get energy from eating and from drinking. You burn calories even sleeping and talking and moving.
So we're burning them right
Energy can help us do different activities like play on your phone. I don't mean electricity. I mean you yourself use energy. Correct. That's how you walk. That's why babies get a little less fat when they start walking, because they're burning energy, right? Toddlers are a little less chubby because they're walking. Trust me, Mila's running all over the place. Okay? She's a little less chubby because of it. All right? We're having to chase her all over the place. Okay? Energy can help us do different activities such as running, walking, playing sports, using the phone, using the iPad, even sleeping, we're burning energy.
It's just like a car. We're getting injured.
There,
When we're opening our eyes.
class.
Yes.
There are different kinds of energy. Remember us talking about kinetic energy? That's the energy of motion. There's potential energy from position. There's solar energy from the sun. Now, we as human beings don't get energy from the sun. Okay, plants do. We're not plants. It relaxes us. There is electrical energy.
What's that?
All right, we're not going to get electrical energy because we're not appliances. Okay, we do get chemical energy from foods and drinks. All right, that's where we get our energy. You get chemical energy from eating and drinking. Yes.
Is hydrogen energy?
All right, stop the talking. Y'all know the drill of the driving question board. So, our big question, the big overarching question, is how do windmills change wind to light? How do windmills change wind to light? That's the big overarching question. The smaller questions that fit under that one. What is energy? How does energy transfer from place to place? How does energy transform? Great. Two.
We need a group of 10.
so obviously you're not copying down one of those questions I have written on the board. You're writing your own questions that would fit under one of those three questions. Okay? So you're writing a question that would fit under what is energy. You're writing a question that would fit under how does energy transform from place to place. How does energy transform? Okay? So you're writing a question that fits under those questions. Does that make sense? Everybody understand what you're doing? No, each person gets 3 pieces of paper.
But
Give
there's
her,
only
give her paper back. Each person gets 3 pieces of
One.
paper. I need the talking to stop. I need the talking to stop.
You guys have the
Right, 3 questions. Each person, 3 questions.
start now. So you want any questions?
3 questions that would fit under those 3 questions that are already. You're not rewriting these questions. You're writing 3 questions that would fit under each of those 3 questions.
You probably know which question it is.
No? No.
No, I'm talking about the people who are writing them. I know.
Yeah, do not rewrite these questions or you will not get your points. What? No. You're not writing what is energy.
One down to the.
You're writing a question that fits under what is energy. You're not writing what does energy or how does energy transfer from place to place. You're writing a question that fits under how does energy transfer from place to place.
It's a question, not an answer.
I wish
I mean,
Okay. All right, I need all the extra talking though to quit.
So you gave us 3 to put one on each.
Put 1 question on each one.
Put 1 question on each one.
1 question on each paper. I don't care if they all fit in 1 column or if it's 1 per column. I don't care what. Just 3 questions.
That would be easy.
And Megan, I would like you to participate too and come up with 3 questions. 1 that would fit under each of these questions. Yeah, I know it's not the largest. So I'm going to zoom in. A question that fits under each of these overarching questions. Okay, you can either take a picture of your questions on Post-it notes, or you can write 3 questions on a piece of paper and take a picture and send that to me. Either one will work, okay? All right, my friends in my classroom, please stop all the talking. And I need your questions in the next 5 minutes. That way we can post them on the driving question board, okay?
You have to run a name of it.
Make sure you get 3 questions written. 3 questions.
Are you covering it? Put the answers in there?
Other people's questions that they wrote are
Does
there.
it matter if it's 4 words?
3 legit questions.
I put 4 words.
3 legit questions. That's what I'm asking for. Considering the first time we've done a driving question board.
It's the second.
What is it?
I want to go down there and
You can use the words, but it cannot be the same question.
wait, are we allowed to use this word?
You can. If you notice, I put up the AR quiz number for the boy who harnessed the wind. It's on the board for when we do get devices or when you go to the library.
So you can't use the same word, but can it be like close to?
Yeah,
You cannot replicate the question. You need to come up with your own question. You only have a couple more minutes to get this done. You guys, quiet. Turbines. It's on the board. Stop talking. Let's get this done. I should not have to say that every minute, guys. All right. All right. What does energy do? Where should that fit? What is energy? How does energy transfer? Or how does energy transform? Where should it go?
What is energy?
What is energy? Good job. What does energy have to go through in transformation? Does that go here?
Yeah.
Yes.
Okay. What does energy have to go through to get from place to place?
How does energy transform?
Transfer. And if you guys don't know, he has a baby sister. That's why he got it. Because he's one of 3 boys. Joey came early. So
Right.
all right. How does energy work? Where does that go? What is energy? Where does energy transfer?
Place.
All right, sarcastic. What happens when energy transfers? Hopefully Carson doesn't get zapped because they're holding a metal screwdriver. Been there, done that. Kind of hurts.
I finished.
Why is energy in food? That is a good question. Here's that one.
What is energy?
What is energy? Good question. How do wind turbines collect energy?
How did energy?
I think it's this one. Don't you transfer from place to place?
Yeah.
I guess
That's
so.
a really good question. How does energy in your body burn off? Good.
How does energy
I
transform?
think so too. What does energy do?
That's the same one I did.
How does energy work? Right here. Copycat. How many wind turbines can transfer energy from place to place? I'm
That's
gonna put
really
that here
what
'cause it's
everybody
really
always
close.
says.
You got two of them. Whoa.
Yeah.
His is really scary.
It didn't happen to me. I didn't do it.
Yeah, it didn't trip one. How does energy do something? Jerome, someone help me. What is energy? How does energy travel house to house?
How does energy transfer place?
All right.
That one was really where you said
How energy changes? How does energy change?
What is energy?
What is energy? How does energy travel?
How does energy transfer place to place? Place to place.
What is wind energy?
What is energy?
Why does energy make lights?
How does it?
what is energy?
What is energy? Why does energy go from water to a city?
How does energy transform?
How does energy transfer?
Or transform?
Yeah, that's what I said. Transform. Right, what's it?
Where does energy go?
What is energy? Oh, how does energy transfer place?
How does it, what is energy?
How does energy travel?
Transfer.
How does
energy transfer place to place?
How does energy work?
How
What
does
is
energy
energy?
transform? Right?
Oh, that wrong, girl.
How does energy transform? Dude, trash.
He said the same thing.
How do you make energy by running?
What is energy?
What is energy?
What is
How does energy travel around the world?
How does energy
How does energy
How do you make energy?
What is energy?
What is
How does
energy?
energy look like? I don't want to get
Injury. Injury? Okay.
Stop.
Why do we have energy?
What is energy?
Oh no. Why does energy transfer?
How does energy transfer place to place?
Or that's always- Why does it transform?
Oh.
That's a good one.
How? I
Yeah,
said,
we
how
have
does
no
it
Why does
work?
it? You say why
How
does it?
does it?
All right.
How does energy transform? 4, 10,000, 100,000.
What?
How does energy work in a windmill?
What is
How does
energy?
it? What is energy? What is
How does energy transform?
Injury.
How does energy work?
What is energy?
What is energy? How does energy travel around?
How do you transfer place to place?
How does energy come from the wind turbines to the city or town?
How does energy transfer place to place?
Where does the energy go to?
What?
How does energy transform? No.
How does energy
Transfer.
Can energy come from water? Great question.
What is
What is
energy?
energy? What is energy? What is energy? No, transform.
How does it transform?
No.
Yeah, I think it could be any of those. I think it could be
I don't
any.
get that question. Who made that?
If it's any.
All right.
Because the four questions that you have about
All right. Bottom of page 8. choose your favorite question that we just wrote on the driving question board and write it on the bottom of page 8.
Can we go look closer?
All right, listen to me. Nope, sit.
Are we fixing my-
Nope, sit. First table. Go.
Oh, no, he's first table.
You guys have 30 seconds.
Half a
Can
minute.
we write one about each column? or
No,
just
one
column?
question. You got 30 seconds. Hurry up.
One for our question. One, two.
I need everybody quiet. All right, second table. Right. Second table. That's right here behind me. Come on. I need my friends quiet. All right, third table. Stay with you. Stay with you. Keep it talking.
Does that only have to be ours?
Nope,
They have to be someone else.
nope. Anybody's question.
Don't be ours.
Thank you.
All right, stop the talking. All right, Aaliyah and Hunter, come on. Oh, come on up here, Aaliyah, with your question. Sorry.
Can we write that in? I couldn't look.
Nope. I forgot to get Aaliyah's question. Where does the energy go?
I should look that. Can I write that?
You want to?
Yeah.
Where does the energy go? How do you get energy from moving? And how does energy work? Pick your favorite question. All right, I need the talking to stop. Logan and Maya. Come on. Leave your notebook open on your desk and I will grade it during enrichment.
Can I have sticky now?
What is it?
I have another sticky now.
Why?
Because I'm the virtual